Good evening, everybody. Thanks for coming out on a night, severe thunderstorms. I guess free pizza brings everybody out. My name's John Pierkowski. I'm the vice chair under Tom for strategy, and I'd like to kick off. This is our fourth Tech Talk, and the other three that are given, you can find them out on YouTube. Just search Johns Hopkins Tech Talks, one word. You could find them. And so tonight the talk's going to be on DevOps, a new software development paradigm. And many organizations, many people all deal with trying to develop software in a efficient, affordable manner. So we have a new paradigm in this day and age. And our speaker tonight is Mr. Jeffrey Garonzik, who now serves as the Director of Operations and Data Science Infrastructure at CIA. And he brings to that position over 30 years of experience, both government and industry. And he has a bachelor's in computer science from Shippensburg University, a master's in systems engineering and technology from EP, Johns Hopkins. And he was a student of mine back a long time ago, great student. And he's an MBA from George Mason, and he is pursuing a PhD in applied information technology. And he's also one of our new EP instructors who's getting great reviews so far, and so he's part of our EP team. So I'd like to introduce Jeff Garonzik.
I'm Jeff Garonzik. As John said, I'm a prior student, Mr. Sanchfield. I had your class in Java, a humbling experience. I learned a lot from all the teachers, and I never thought I would end up being able to try to teach, particularly in this forum, to teach you all is beyond what I ever thought I'd get to. So I was asked to talk about DevOps. DevOps is one of those buzzword terms. It's kind of new. I haven't heard it for more than a year, maybe a year and a half. But if you do operations at all, if you ever make software and put it into use, you probably do DevOps. You just don't do it at the speed that what DevOps today could offer you. Maybe you do. It depends on how agile and how long you've been doing your project. DevOps is kind of a mindset. I've been working on assembling material to make a course with several other people, and the books out there are really bad. They're just not mature enough. They're not consistent enough. The terminology, it's used, they call it marketecture or whatever, they just make up uses of it. So I tried to capture what I think it is. I referenced a lot of sites. So I'm a CIA employee, 16 years. 8 years before that I was a contractor, and 8 years before that I was in industry. I've done software development. My native language is Fortran. English is a second. So a lot of the DevOps stuff being so new wants the object-oriented languages. And there are really, in my mind, there's four if you're going to invest in new language development, Java, Ruby, C++, or Python. And then there's a lot of other ones. I think I knew 25 languages when I graduated with my undergrad. The only one still in use today at all is C. So the challenge is, how do you learn new languages? How do you learn new tools? And a big part of DevOps, in my feeble attempt to quantify it, is a tools inventory or a tools assessment. And you'll see some lists of tools here that are really a little bit intimidating. You're not going to know every tool. So the idea with DevOps is pick the tools that you're going to use, pick the skill that meet the skills that you have available to try to accomplish the task. So anyway, DevOps, it's looking for the synergy between agility between development and operations, where development wants agility and operations wants stability. Somehow they have to communicate. That's the arrows in the middle. So that's a very simple drawing. Excuse me. My organization has rules about what I can write and what I can publish. So much of if I were to write a book or write a briefing like this, all on my own, I'd have to submit it for publication review, a very long and drawn-out task, and it means putting my pencil down for a while. DevOps never really quite finishes. So I use those things to make a few slides of my own. I harvested material from internet and from many sites, and I did reference the sites. I need to complete the actual references into like MLA format at the end. It's not that good yet, but it should be. I did try to attribute where I got everything. If it says it at the top, it says what site I got it from. Otherwise, the material in here, Chancellor Pascale, he took a shot at doing a tools inventory that's modern, or that this semester's tools inventory. So he did a lot of the gathering of the materials that are in here. I taught a class in software engineering, not last semester, but the semester before it. And I used Sam Chappell's material as a guide. I had never taught software engineering, but I really had done those skills my whole working life, nearly 30 years. Although teaching that class to his standard really made me open my eyes as to what some of these practices are. So requirements capture and how you test your black box testing, white box testing. It reintroduced me to a lot of the formal methods. So I guess I don't want people to think that this is the end of DevOps. This is all the answers, but it's DevOps as best we could identify it. So anyway, DevOps, it's a methodology. It's software development. It's a lot of communications, a lot of collaboration. It really tries to, as quick as possible, produce things that are of need. So it builds on models like, welcome. It builds on models like waterfall and spiral and agile. It's an extension of agile, but a continuous agile method. Per wiki, here I swipe this. It tells you where agile comes from. It's been around as a term. Agile's been since around 2008. I think the term 2009 they coined the term. I think my functional definition of Agile is it's Agile methods in software engineering. So it's not just Agile software development, it's those tools that you use that Sam Chappell teaches in software engineering, doing that in an Agile way. So flexibly, quickly, iteratively. DevOps requires lean. So lean, I summed it up in the last bullet. If whatever you're doing doesn't add value, don't do that. It's pretty much that simple. That means you're going to be continuously pruning the standing order of business. Whatever your process is, it should always evolve. You should always question. You don't need to say, I don't want to do it, but if you can't see why you do it, you need to then ask that question, do we need to do this anymore? Because if it's not adding value, so lean actually came from, I think, Toyota many 20 years ago, but it's fundamental for DevOps. It's self-pruning, and it keeps you on track. So I think the actual definition, they call for perfect value. So you're never quite there. You're always kind of looking for what can I take out of my overhead. But I don't know how you can do DevOps unless you practice lean. I know one of the problems with my organization is we put in bureaucracy, we put governance in, but if you're not getting value out of it, if the inventory of systems just checks what the product is that you want to add to the enterprise before you bring it in, but it never trues up that inventory, if it never takes anything out, what's the value of this governance? If you can't ask it, what's in the fleet? Or how many versions of PowerPoint, or how many versions of Office, how many versions of any product are out there, then you're not getting value out of the governance. And I would question, why do you do it? You need to fix it so you get something back for it, or don't do it. And that's lean. But that's a term that's required to achieve DevOps. DevOps is sort of a simplified process. This is a simple way to think of it. You release your software, so you make your changes. And so I'm not talking about requirements or what encourage the changes, but from the standpoint of I made changes to the code, I check it in, I manage the configuration, I build it, I test it, I put it out there, and then the continuous delivery, I have a slide on that. And then we watch to see, is it in compliance? So one of the the tools that I talk about, Puppet or Chef, those are automated build tools. And one of the concepts, one of the problems that I've seen, we build operating systems and we put them out there, and then the patches start to build up, and we try every month to determine, are these patches in place or aren't they? If some of the systems are patched and put out there, we don't have a good common place that we build and assemble them. So DevOps, and I'll talk about that in upcoming slides. But if you keep track of how you build things, just from the standpoint of build by recipe, so instead of having a developer build it and give you the executable, if you put in governance that says, here's my list of what goes into this, here's how you make it, and here's the code, and then you make the actual operations side, build it, test it, and deploy it, you always know what went in the soup. Okay, many times we're just given this pot and we don't know what went into it. So it's hard to reproduce it. Now you can always image things and reproduce what you had, but you can't build on it very well because you don't know what went into that soup. So if you can build by recipe, the operations people are able to accept a patch, put it in, build it, and test it, and if it tests clean, you don't have to reconvene the development team again. For a change, the operations people can put a patch, promote it to production, and use it without having to gather all the people that made this thing. So that's part of the problem or the challenge that we face in my organization. We see an idea, it's typically in industry, we give a project manager a bag of money, and they take that and they convene a team that they're comfortable with of their own skills. They take the product from industry, they get it working about 80%, they secure it about 30 or 40%, then they write a list of exceptions, things that they intend to fix. But when a new tool comes out, the focus changes to the new tool or the new product, new capability, and the focus shifts. And the product is left to languish. So we're unable to patch it over time. This is what I'm describing is building by recipe, and we'll talk about it here in a minute, a better way. So what's different from DevOps to Agile? It's kind of a process rhythm. So we're going to do DevOps continuously. As soon as we're done, we start over again. And you keep on going as long as you can. It's going to take some maturity. It's going to take some experience to know what standards of documentation you need to leave behind for the legacy. Okay, so you need to document just enough. It's one of those, this bed's too big or too soft, this bed's too hard. You've got to find the one that's just right. So you need to write enough documentation so that ideally you or somebody else is going to come back in 3 years or 5 years when that operations team tried to apply a patch and couldn't. And you're called back to go, you need to be able to checkpoint and know where you left off so you can apply a patch properly. So as you can see, patching is one of our big problems, or challenges. So how do we get started with DevOps? Well, here are the steps that occur to me. So you take a tools inventory. It may be tools that you have, maybe tools that are open source, and maybe tools that you own, and maybe just emerging technology because some new tools might have come out since the last time you made a tools inventory. But you need to know what's available to you. You need to know what of the people that you have, what skills do they have with respect to those tools. You're not going to pick languages that people don't know, but if you stay with those 4 that I described, you can pretty much stay to most of the modern ones. So I can't say that I think in object-oriented, I think in procedural programming, but I can convert to object when I have to. That's not, the new kids coming out, they are object 100%, and that's where I think we need to encourage people to get. We need to look at the tasks that you want to accomplish. And I had a lot of thought on this. Depending on, so from years back, we typically had batch programming, where you had a series of transactions and you just wanted them done, or you had interactive stuff where you would be presented screens of status and you'd type in some information and you'd get some results. Today, we have yet another more common thing, they call it data science, where people, typically not computer people, but mathematicians, statisticians, with some mathematics or some programming background, just enough to be dangerous, they want to do one-time run to figure something out. They may never run it again. So, but I think all these things, DevOps and data science, are really related. Data science uses DevOps methods. They just intend to only do it one time. They're not after doing the payroll every week. They're trying to find an answer or get some insight, validating what they thought, or trying to determine something new that they didn't know before. So you look at the task to be accomplished. Then you're going to need to pick out the tools. The number of tools is astounding. I mean, you'll see it in a few slides, how many tools there can be. So emerging technology, it's immense. I couldn't even get close to knowing how many different tools are, but I have some favorites. I have some that I like, some that I'm proficient with, and some that I intend to go study about. And that needs to change every 6 months, maybe, every year. And then you determine in your team what assignments the people have, what responsibilities they're going to have, what tools they're going to need to do. And I'd like to think that DevOps is language neutral. You should be able to do DevOps in bourne scripts, right? You should be able to do it in BASIC, in whatever language you're going to write it in. Just look at the tools, figure out the skills you have, and what is it you want to try to do. So some of that, like I said, though, the more mature you are, the more experience you have, the better it's going to be. So I'd like to think that you're going to need somebody that's a Jedi, somebody that's got a lot of experience and going to be able to coach the people into selecting the right tools, doing the right practice, putting just enough governance in place that it adds value, and get to work. So from the new Relic site, they had a DevOps lifecycle. I changed it quite a bit, but that's where I sourced it from. So you make your code changes, you check in the code into your source code repositories, we'll talk about those. Then you pull the code, apply the patches, build it, and test it. All kinds of different testing. I like the idea of a build repository. That means you build it to one place and then deploy it from that one place. That allows you to push it or pull it, doesn't really matter, but you have one pristine place where the built copies exist. And it also, if you expose it to the fleet, particularly the checksums of those builds, you can check, is something in the wild correct? Or has it changed since it was pushed out here? Maybe I need to rebuild it or re-pull it. Configure your environment, update the databases and the apps, put it in the hands of the users. Do your monitoring and repeat it. So I said about monitoring. So you need to put in place monitoring that's going to tell you when things go out of spec. I was overhearing a conversation about controls and security. So my background is security. I've done computer security for 25 years. Today, in government classified environments, they want you to A&A, assess and accredit. Wait, let me see. It used to be certify and accredit. Now it's assess and authorize. So we have to test to specific controls, and you either meet the control or you don't. How do you determine what controls are going to be tested or what pieces are going to be tested? Well, that's where the real problem comes in, because it's difficult to devise the tests across many, many different platforms. And the basis of this is that you're supposed to use standard design models and inherit the changes. If you use somebody else's build for maybe an operating system, or for a Tomcat web server, or a implementation of MySQL, you should be able to inherit all the controls, providing you can maintain your configuration like theirs. You should be able to inherit their controls without retesting, and then build put your code on top of that, test your code, and move forward. So imagine how much easier that is if you can build this by recipe, layering these pieces on top, checking the checksums against the deployed builds, and then saying, I've tested that, or I'm just like those other changes. As long as no patches have come that I need to update this Tomcat web server, I can build on top of that. So anyway, this is the a example of a life cycle for DevOps. By the way, I didn't offer. If people have questions or comments, please bring them in. I don't claim to be the authority on DevOps. I'm just the guy who tried to assemble some slides and make a good argument on how we could possibly teach this. So these are some examples of just a few of the tools. We're going to see 100 tools. We're not going to go into 100 tools, but I want you to see the number of possibles that are out there. So these are release tools, CM tools, orchestration tools, monitoring and visualization tools. Everybody working in clouds yet? We have Amazon, Azure, what else we have? Rackspace? No. So we've been working in Amazon lately. That's been my area of study. Amazon has some specific pieces. OpenStack, that's the one I wanted. Anyway, Amazon has been the area of study for us. A lot of the Amazon specifics are trying to automate the way DevOps works. So I don't want to talk too much just about Amazon. They're just a cloud vendor. Ideally, you'd be cloud neutral, and you could do DevOps in any cloud or in any physical box. Oops. So, as I said, I had written a single day on DevOps in the software engineering course. I asked Chance to come up with a current tools inventory, and he did it for this semester, and these are the 10 areas that he did a poll looking for different. So operating systems, it's not really a DevOps thing, but if you don't have an operating system or a virtualization platform to do it, or an infrastructure as a service, some way to start, you're going to need to know what's available out there. Software development, testing, CM, deployment, monitoring and alerting, caching and queues, webs and servers, security and dashboards. He's got tools that he's inventoried on in every one of these areas. Some of them I had started. He's really done a great job at it. And now it's about a month old. In 6 months, it's probably going to need refreshed. So the nature of emerging technology is you're going to have to continually look and see what's coming and what's worthy of consideration. And a little bit of that's the governance thing that I said. You're going to, if you can only support 5 choices in testing, you need, if a 6th one comes up, you need to drop one of them off. So how are you going to make those decisions? Ideally, you're going to let people, the skills of your team indicate what things are best for you. But that Jedi person, the person who's coordinating DevOps, they have sort of the responsibility to encourage change when it comes to the tools. So we're going to talk about, this is module 1, and these are the different tools that Chance found. So literally, this is where I'm at with respect to assembling a course. We have 10 modules, and for each module, he's done an evaluation, or at least about a page that describes, for example, Linux. The OSs are Linux or Windows, different virtualization opportunities, or infrastructure as a service products. Here he discusses Linux, some of the common choices. It's not constraining, but it's supposed to be guiding. CentOS is very popular. SUSE, I use Fedora. It just depends what you're familiar with. So you're going to need to get an operating system. You need, from my standpoint, you're going to get the tools. You're going to load them on there. You're going to have to harden it so that we have a lot of security issues. You have to apply the patches. That alone, to the fleet that we have many different versions deployed by many people. I think if we're going to do DevOps, the more common you can, the more building by recipe, the better you're going to be able to support multiple in-flight versions. And back to that governance thing, the number of versions that you want to allow, that's something that governance should influence a lot. You should be able to look at your dashboard and say, I have 3 versions of Linux that are supported. I'm going to add a new one. That means end of life for this version by this date. How many does that affect in the fleet? If you pre-wire this stuff and keep track at the time you deploy and true that count up on a periodic basis, you can get that insight. So DevOps, it's kind of a way that we can knit all this stuff together. And for new systems, for the legacy, I don't have a lot of answers. But I would say every new dollar invested, if you do it with methods like this, you're going to slowly grow into compliance. So you're not going to fix the old ones, but you're going to get some insight into what it takes to build it right. And with that insight, you could then apply it to either the most critical systems or make some inferences about how much it would take for the fleet to get healthier, to get to this consistent state. So many of these other slides, literally I'm just going to fly through the slides. I'm not going to read these slides. But so this is module 1 on OS virtualization. And literally there's a slide for each entry that describes the product. So virtualization, there's XenServer. There's some bullets about it. And I leave these slides, or I'll give you these slides. In fact, I can give you all 10 modules. I didn't put all the slides for all the modules in here. But that's the basis for a tools inventory and a good portion of the work to develop a course. So these are common tools, and it's a challenge for me to try to know what they all are. KVM, these are hypervisors, the VMware, Hyper-V, which is Microsoft's product. Again, I'm not going to read these slides. Docker. So they're all very popular tools that have to do with how you can do many operating systems agilely. So here's module 2 on development. These are all software products. I don't claim to be guru of all of them. I don't think I'm guru of any of those. Maybe Beanstalk or App Engine, and that Heroku, I guess I can explain. But these are all tools. Pardon me? Sir, please.
When you showed the hypervisor,
Yes. Which one?
are the hypervisors secure?
I don't know. Are they? So the question is, are the hypervisors secure? We could talk all day on that topic. Back from emulation, a hypervisor, there's two kinds. There's bare metal ones and there's software ones. Today, they're mostly software. Hypervisors allow you in one operating system to run multiple copies that are supposedly separate of others. It's the basis for the way clouds work today. Google and Amazon. Amazon's based on Xen. So you can run these things at home. Are they secure? Dr. Longstaff, are they secure?
Or some definition of the word secure.
So they're complex as heck. There you go. But how would you know? I mean, if you do just pure back to computer science, the number of lines of code and the number of bugs you found versus the number of bugs you haven't found, there's statistically always bugs you just haven't found yet. And then there's these novel approaches that nobody would have thought to try. Cross-site scripting, there's some elegant hacks. Are they secure? Depends on what you're trying to secure. If you're trying to secure time and attendance, they're probably secure. If you're doing financial transactions, well, they're secure, but you limit the transactions up to a certain dollar amount. A credit card transaction is only good up to my credit limit, and as we talked about before this lecture, if I go out of bounds, if I go buy boats, if somebody has my credit card and buys a boat and a car and a house, they're going to say that's out of character. Or if they don't hit my credit limit already, they're going to stop. They're going to make me call in. Hypervisors, it depends on what you're trying to risk. If you're trying to risk monetary transactions, I mean, Amazon makes a living selling hypervisors. Google makes a living selling hypervisors, and companies do it all the time. Are they secure? When you get a physical safe, if you look at those things, they say they're good against so many hours of man manipulation. If you have that safe and you're in the middle of a field and you got a backhoe and sledgehammers, you're going to get in it eventually. I think hypervisors are probably the same deal. Depends on how badly somebody wants to get in it. And are they going to be able to get in it and get out of it without leaving a trail? So there's a lot of questions about secure. If you're a US company and you've got other companies that are US, maybe that's okay. If you've got foreign companies and more importantly, foreign nations that are trying to get in, if they have infinite resources, they're probably going to get in. So back to putting the security hat on, if you can't afford to risk it, don't put it in there, right? If it's something, if it's the secret to Coca-Cola or Kentucky Fried Chicken, you have no, or RSAs, fob tokens, don't put the seeds out there because eventually it's secure up until it's not. And when it's not, and you're OPM and you lost everything, sorry, I don't know if that cuts it.
How about the bare metal versus the operating system environment?
I think bare metal's better. It's a lower attack surface. Is it better? They're still complex as heck. On the other hand, bare metal, you can't really change it so well because once you make silicon, it's hard to change. It's expensive. So a lot of bugs, you just say, I'm not going to talk about that one. When's the last time they recalled your Samsung Galaxy 5 and said, oh, sorry, we had a problem, let us fix that for you? I mean, it's got to be dire before a company's going to say their reputation's at stake enough to call it back, fix it, and give it back. They're more likely to make the next ones better and maybe give you an incentive to move. But so hypervisors are, but outsourcing IT and not having my own data center, there's a lot of compelling reasons that people want to go to virtualization. For one thing, one computer on your desk and lots of flavors. I can do Hackintosh. I can do Linux inside Windows. I can do Windows inside Linux. Any way you can imagine it, you can probably do it. So today, I can buy the lowest cost. I can buy a Chromebook. I can connect to something, and it'll, via X Windows, I'll connect to a PC that's remote. You're limited by your imagination. So I think hypervisors are unavoidable. Just got to think about what you're putting in there. So if you have something that you can't afford to lose, I mean, if you can't afford to lose it, number one, back it up. And number two, don't expose it in places where it doesn't have business being. So convenience is a poor excuse to say I didn't want to have to get up and go open the safe or go across town to get to where. So I hope I answered your question.
Terrific. Thank you.
I wish I could talk about DevOps like I can talk about security. So anyway, developing software, there's lots and lots of choices. And like I said, I'll put these slides up there. And I don't want to read every one. I can't do them justice. But literally, in these slides is a few sentences about each product, what it does, and where it's appropriate and where it's not. So if this guides you or helps you learn about DevOps tool inventory, I want to extend it to you. So Git is worth talking about. So Git, GitHub, GitLab, there's a whole bunch of different Gits. They're all a little bit different. Some cost money, some don't. Git's a version control system, and we've had lots of them back from CCS, where we used to be able to get a piece of, pull a piece of code from an archive, make some changes, say it would diff. A diff, it just looks at something from the way it was to the way it is, and just saves the differences. And it applies those differences in organized branches so that I can say apply version 1.2.3 and show me that, and compare that to version 1.3 and tell me what lines of code differ. So Git is this distributed, free way that you can do that with code. It's a real cool product. There's Git and there's GitHub. GitHub's a web page. You can publish Git repositories and you can share it with other people. It is what I described webified. So it's the old source code control systems in a distributed fashion so that you can share it with other people, publish it to the world, and maintain reasonable code availability. So it really doesn't do availability. It does, so the way it's distributed would answer availability. It does code branching and changes. So there's the website, git.com, or it's git.something.com. It's very simple. It runs on multiple platforms. You can get Git for Windows and for Unix. But it's Git. This is a different version. GitLab is different. Git is a critical piece, and I think it's probably going to be a common piece of almost all DevOps efforts today. If you're going to try to keep track of code and manage the changes and share those changes among other people, Git or something like it is going to be important. So let me jump past most of these. So these are, here's module 3. So I'm not going to go through all the different products and all these other modules. I'm just going to show you the single sheet like this that tells you what tools are discussed in the module. So this is on testing. So a critical part of DevOps is testing. And there's a term, and I think I have another slide on code coverage. The more we can automate testing, the more consistently we can produce a product and identify bugs. So the way we do it, the way we've done it, people build a code base that's unique to them. They don't share anything. They make an application, and they give it to security, and security goes and gets a tool, Nessus or products like Fortify that can look at the code, or Veracode, and they look at it and they scrutinize it and they point out the problems. But that takes time. They write exhaustive reports about why it's bad. They give it back, and the people who get the reports stick their finger in the dike. They fix the easy ones. They write a list that says we'll get to the harder ones unless it's something critical or something really exposing. And they may or may not get around to fixing those deficiencies. DevOps is an opportunity to automate testing. So one of the big ones is JUnit. And I'm not a Java guru. I know you got some Java gurus in here. JUnit can automate a lot of the Java testing. So you can have, so the bugs that are problems, besides the ones that just don't work right, the ones that allow things unintended to happen. So we've long had, so anybody familiar with Hacking Exposed, those kind of books? You know what I'm talking about? You know, it's easy enough to test that a product does what you wanted. The way it fails, though, is also equally important. Part of hacking, or part of exercising tools to see if they work right, is to hit it with unintended, maybe illegal, non-compliant information and see how it responds. So you can ping a host, but the way it responds to a ping that's malformed may indicate to you much more than just the host is there or the host is not or the host is answering ping. It may say, oh, I know that's a Solaris version 8 box that's not patched for ICMP because of the way it's behaving. So there's a lot more to testing, I guess, than just making sure it works right. You need to know that it fails right. Okay, so we in Sam Chappell's class, we talked about black box testing versus white box testing. One, you know what's inside. Sometimes you just are testing the inputs and the outputs. Sometimes you're just testing the requirements to make sure the box behaves as it's supposed to. So the more complete you can cover the code that's in there with the test cases that you write, the more secure, the more confidence you should have in the code. So if there are sections of code that never get executed, or there are sections of code that get executed that should only be executed when certain criteria is fulfilled, but somehow ends up being executed inadvertently through some way it shouldn't, that's stuff you want to know about before it gets deployed. So that's the kind of testing and the opportunity that testing can give you for DevOps. I would like to think we could build a lot of the security compliance testing into automated testing. That would shorten our time to get it through the compliance people and provide us a more consistent product. So security, my hope is automated testing, because budgets are shrinking and tolerance for 3 weeks to evaluate it with secure products is kind of waning. Sir?
In terms of testing, where do continuous testing tools like CodeMonkey fit into the operation within DevOps?
So I'm not familiar with OdeMonkey.
These are the things like you're constantly breaking the system even while it's in production.
So we have many tools that can go out and harass an online networking, or an online network. Some of them have to do with not only hitting with malformed packets, but with load. Sometimes it's hazardous to hit particularly legacy systems with loads that they weren't intended to receive, and it causes failures just inadvertently. I think part of it is cloud, so you can spin up copies that look just like the real one. You can spin up loads that behave just like they're real people, and then hit it with tests without damaging or risking people. So I think the answer is part of that, partly hypervisors and partly on clouds would give you the opportunity to get the kind of testing you're describing without risking the transactions that are legitimate. That's a way. I don't know if it's the way, but that's from the security guy, how I would approach it. So partly I'm drawing on security experience and a little bit of operations experience.
Well,
Sir.
I don't know how you're going to order things in the follow-on modules, but when we went from a platform to testing, there's one layer in supportive testing that I found essential, was basically installers, migration, the ability to get from end to end plus one, so that when you talk about automated testing, to be able to say, here's the versions I want, get everything stood up in this configuration, now let's run the automated testing. And that may involve migrating, taking test data, installing it at a database at this version, migrating the database up to the current version. So it's basically getting people tuned in of building RPMs and installing it in a way that you can version.
So I tracked what you said. What was the question? I'll do Tom's job. What's your question?
About automated testing, to me, one critical piece of automated testing is to automatically install things.
Sure.
Is that in another module, or so one of the tools that I didn't see so far is installers, RPMs, being able to package things, develop packages that said that administrators can just basically push push buttons and get there, and tools like JUnit or in some kind of Jenkins job say get this machine up to this spec before we start running the test.
Let me jump back. Well, it's painful. So we talk about deployment. Let me jump when we hit 5. Okay. So, but it is a little bit of a science. You're going to package things up. There's a number of ways you can package products for deployment, depending on the operating system and the skill of the people that are doing it. Dependencies are an issue. They always are. Some things require other things to be installed. How many times do you have .NET inconsistencies or things that need to be installed? Let me get to slide 5 in deployment and see if we touch on them. If we don't, I'll be glad to add them. I'll talk to Chance and say, hey, what about this? So we talked about testing. We're going to talk about code coverage. Let me jump forward. There's deployment tools. So RPM is one of them. I don't have the slide for RPM on here. I definitely have it on my laptop. So that's something that I want to pull up and show you. In the last couple minutes, I will pull up the deployment tool slide. So I specifically didn't put all of them in here because it would be too many slides. But let me go get the RPM one. And in fact, we can go get all the deployment tools, and I'll show them to you. In fact, who has the access to where my slides are? You have the USB drive still in?
But not so much a question as a comment that in your stressing that automated testing is important, I find the main inhibitor to automated testing is setup. That people say, well, I've got to install this, I've got to do that. And I'm talking about versionings and things of that nature and getting your tests in places. On the projects that I've been involved, the project that I was involved with, where they said, we're going to take the pain of putting everything in an RPM and do the automated installer, automated testing became a breeze. If you wanted to test a particular version, it was a breeze. But we had to go through a lot of work to get there. It wasn't free. But
I absolutely agree with what you're saying. I wish I were skilled enough to answer what it takes to build an RPM. I have not done one. I think the install products like XenServers and the convenience of doing it in a consistent way, particularly automating those builds so that Puppet and Chef is able to pull exactly what you want and build it into a. So in many cases, we're fighting this fight now in data science. do you build a data science full-featured workstation that loads everything, or do you just build the ones minimal and add the ones that you want? So I think I'm struggling with your question, though.
Sure. In my current project, we use JUnit. We use
Right.
some things that people will call automated testing, but it's not. There's a human that did a few things ahead of times because they haven't put in the investment to do automated setup. How did I get the database to be in a certain state? How do I get certain conditions to be met? And basically going through the automation of getting your environment up to a point where you can run these automated tests.
Okay.
Is the point that, yes, I applaud automated tests and stuff like that, but the main inhibitor I have found to doing real automated tests beyond unit tests is, integration tests,
Sure,
full
IVNV
threads,
and
things
all
like
that, right.
is the lack of work in things like packaging things up in RPMs and being able to get to a particular repeatable state, starting state at the start of all your tests at a push of a button.
So again, I would hope cloud is going to offer you opportunities to instantiate entire ecosystems and simulate it with dummy test data, which is really the only hope that the problem is if you're working in an environment for us where you don't, even a developer doesn't get to see all the data, somehow you have to have data that's representative of all the cases that they're going to have so that you can make test cases that can adequately stress the areas that have changed.
Yeah, I think he's talking about setting up a nearly live environment and having an automated mechanism to make that happen, make it easy, so they can focus more on the testing as opposed to setting it up.
Yeah, and then once you do that, a year later, all the database migrations, all the changes that have taken place, you can now take that test and migrate it forward so that the test no longer becomes invalid. You can keep running that test for a year
clearly.
while those things are going on because you're migrating it as if you were the operational system.
Right.
So at a high level, just saying automation of getting you to a known starting point,
Right.
I found to be quite critical
Okay.
to doing automated testing. And without that piece of the pie, there's a lot of manual work that goes into it and a lot of regression testing that doesn't get done.
Very good.
I think that's a big part of when you start talking about deployment and configuration management. Configuration management is really the key there, making sure that you know exactly what you're going to have on your system and you can recreate that system consistently and preferably through scripts.
So other things that come to mind. So cloud gives you the ability to simulate it offline without damaging potentially live data or live users. The ability to checkpoint where you are, and just like journaling that we had in old database systems, if you can roll it forward, roll it back, or preserve it as a use case so that you test it in the future to make sure that never happens again. So anyway, I don't think I did justice to the deployment tools, but if we have enough time, I have the USB drive here. If we have enough time, I'll pull out the slides that have the data on it. That's why it ended up.
We will post all the slides afterwards.
Very good.
On the website.
All right. So but there's literally, for each of these deployment tools, Chance has made one page, just like these prior ones, that describe the pros, cons, and where it exists, the current state of it in industry. So anyway, on testing, I gave a little bit of discussion on testing. Code coverage, I kind of described what it's about. It has to do with, can we exercise all the parts of a program before it, or of code before it gets deployed? CM, these are different tools for either operating systems or for languages that let you maintain a static configuration. So Puppet and Chef are both very popular in environments that I've seen. I described Chef a little bit. Puppet, I think, is more popular where we are. I think the jury's out. And I didn't really describe how I would like to see a DevOps course taught. But remember back to the slide where I said you assess the tools, assess the skills, determine the task that you want to accomplish. then you're going to have to down select from all those tools that are possible to those tools that fit the skills or the desires of the people that you have, constrained by the time that you have to learn it and use it. So you'll pick some of these tools. I'd like to think that DevOps doesn't require you to use Puppet. It would allow you, if you want, to use Chef. So every possible instantiation of DevOps, could you have a different selection of tools? So there's probably a top 10 that are popular today, but I don't think they're the same 10 that were popular 3 months ago. Kind of depends. So on the other hand, once you get something in flight, it's not so easy. You're not going to be able to change 90 degrees. You're going to be able to change a few degrees or change one product in and out, or maybe add another product to it. So I mentioned deployment tools. These are management and alerting tools. And there are, for each of these, there's another slide that describes the utility of each of the products. So this is not to be a discussion of tools. You're seeing the tools inventory that Chance put together. It's very comprehensive. These are caches and queues. I'm familiar with a few of them. Amazon Simple Queuing Service, Memcached. So you kind of learn how to use some of these. You may be expert in one or two, but that's what the field looks like. So when you go hire people, they maybe are going to have some of these and not have some of the other ones. So as you form a team, you have to look and see what skills do they have and how long is it going to take. If one product is like another one, maybe they can jump that pretty quickly. Different web servers and application servers. There are lots of them. You can have a class in just Tomcat. Python, so I'm not sure why he put it there. Security, I did throw the slides on security on there. The only ones that I'm very, very familiar with here, Fortify and Amazon, Centrify a little bit. So I'm a security guy and I know those three. The other ones are products, and I could probably read about Cypher Cloud. I know I've heard about it. These are all products that are out there. So looking at the different security slides, the different security products, so there's Qualsys, describes what it does. So these are just slides that I knew, because Dr. Longstaff was here, I threw the security slides in while we were in 10 minutes while I was eating my pizza. So these are the different products. Let me find the ones that so there's Cypher Cloud. It's a single sign-on product. Wait, no, I'm sorry. Centrify is a single sign-on product that it's used with multi-factor authentication. It can be leveraged on Hadoop and also some normal non-Hadoop activities. Fortify is a code examination. It looks at the software and it identifies improper or discouraged coding practices, sometimes downright wrong coding practices. And the coding practices are things that allow unintended or exploits to occur. So it identifies problems in your code. Fortify on Demand works on web security. So Fortify looks at actual source code as well. It has a whole list of codes that are supported. I don't think it does Ruby yet, but it does many of the popular ones. Amazon, that's their IAM service. It does multi-factor. It's a public key, makes a secure key, a key pair, so that you need to have the key to be able to connect back into the resources that you create in Amazon. So, but that's a feature that is available with Amazon. Microsoft Azure, it has one as well. They're very similar in cloud products. They're just different by names. So much of the terminology between Azure, I'm finding that there's a lot of parity and capability between Azure and AWS. Just they've named them all. There's no standards with respect to the names of what the products do. So anyway, I'm describing this is all tools inventory. So I want to get back to DevOps. So how are we going to learn all this stuff? I would say, I'm the new guy in teaching here. I've only done it for 2 classes. But I would say we make technical modules. They ought to have self-study, so that if you picked any one of those things, or some of the popular ones at least, you should be able to get up to speed to learn how to install it and use it, and maybe some examples. so that you have a standard of proficiency maybe before you get into the class. So you know what you're going to be expected to be proficient in, at least just on install these products ahead of time, be able to build these products or test these products or be familiar with the operations of something, and maybe adopt one or two as a practical aspect of every course we teach. It's not my place to tell you all how to teach, you know it better than me. But with the number of tools, if we don't get some of these things into the hands of the students, and the classes are the premier opportunity to do it, I would, as a lifelong student, I'd say we're doing them a disservice if we don't make them learn. Sir?
So Jeffrey, can you characterize the tools with regard to how easy or difficult they are to integrate into your automated testing, your automated deployment? Because there's a lot of these tools that have open APIs, but there's a bunch of other ones that do not and require a lot of manual effort. So is there a way to distinguish between the ones that are easy to incorporate versus open APIs and automation versus the ones that are more difficult because they require a lot of manual effort and can't keep the pace up in DevOps?
It's a great point. It's not something that I can say that I have the answers. With some study and some effort, we could probably bin the tools as to their thoroughness and their complexity to learn and the value that they'd add, because in the end, it's supposed to be, remember, lean, it's about value. If the tool and your use of it isn't giving you some noticeable improvement. So, and we're going to talk about metrics. There's still some more meat of DevOps to cover. Not much, but some. It's a great question, and I don't want to put you off. I would defer to the czars of these coding skills or these languages. The way I'm pitching DevOps here is that it is platform neutral, that it's language neutral. Every language, the languages are not Python. I'd argue you can come up to speed faster in Python than you can in some of the other ones. But some of the constructs in Python can be extremely complex once you get into it. I only ever use about probably 1 or 2% of any of these languages' capabilities when I'm writing something, because I don't live in these languages. I'm more trying to get a task done. But other people who studied Ruby for 10 years or 5 years, their mastery and their compiled libraries of code that they're building on are much more thorough than mine. So I don't think I can give, I'm sorry to say that I'm not prepared to answer it, but it's a great question and something that should be answered, because before you launch into this, or before you tell a student, or before you even try and make so I'm talking about just basics, getting to the capable of using something to perform a task. Hello world. Add, change, delete, CRUD database, create a file, manipulate the contents. Make a word processor, open a window and let me change text, insert mode, and track it with a mouse. Those kind of basic capabilities. And that's really where I think this class, the part that I haven't written, would be how do you give them sample code modules in pseudocode for each of those, hello world, a CRUD database, and an application that opens windows, maybe even a client server app that's platform neutral, and have you code it, make it work. So you can even come up, I can even provide example code in Java, in Ruby, and in C++, so to get them started. And then once they're working in it, hit them with some changes. So that would be an applied way to do DevOps. Yes, sir?
So one thing you might want to consider is that you talk about DevOps as one of your stages, if you will, of your life cycle, right? So of one of your stages is selection of the tools. So I would talk about what's the process for tool selection given the problem that you're trying to attack. But oh, by the way, here's an inventory of all this stuff.
Right.
And what the exercise could be is, given this hypothetical problem or several problems, maybe they break up in groups or whatever, go off and follow this general process for tool selection and come up with an environment that you create and then use later on in the course to actually go build something down the road. You might do it like that.
Why not? So I think this is a blank slate. We're limited by our imagination and how we want to teach it. But I think DevOps, it's agile, and it's got a rhythm to it. So I think if we can stay to those kind of themes and stress lean practice, I think there's an opportunity to learn an awful lot.
Just out of the discussion, it sounds like there's some fundamental things that need to be done at setup time.
Clearly.
For example, setting up the ability to automatically generate the test environment that you want to go to spend less time on that. So there's a discussion about that. There's some fundamental things to set up the architecture and the enterprise, if you will, and then have a use case that you carry through the whole process.
Sure.
Might be a way to think about it.
I think excellent ideas. So these are too many words, but success metrics. So mean time to recover or repair, we're looking at from an incident report to its resolution. And it's a shame that these came out in white. It's a lot better if you can actually read it. But but this mean time to recovery, from I got a problem till it's fixed, that shows you the responsiveness of the team and their ability to fix it, and their capability to really deploy the solution. So that's a key metric. The lead time, defining that as from the start of development until it hits production. The team optimizes this metric by using smaller chunks to do small pieces at a time, optimize the integration and testing, and overall it's going to shorten the time to deploy. The number of successful deployments and the projects completed per quarter, those are just stick in the mud, but these are the ways we can measure, is DevOps making a difference? I think it's kind of a cool idea. I'll work on making it more readable. I just changed the text to black, but it looked so gloomy that way. So we talked about the DevOps lifecycle. The new code changes, so that's really going to be driven by business requirements. It's not something that you just make up. DevOps doesn't say, I'm just going to freely associate and come up with changes. So there still has to be requirements, the cost-value decision of whether you're going to actually try to do something, the commitment to actually do it, and then the process as we described it. You're going to use Git, you're going to use automated testing, you're going to use release management to get it out into the field. So that's kind of my show on DevOps, motherhood and apple pie. Everybody wants it. Nobody knows what it really means. So I think as it matures, and I'm looking for the common body of knowledge. For software engineering, there's a SWBOC, what a software engineering body of knowledge. There's no such thing for DevOps. Part of it is that operations is a largely experience-driven study. Sir?
Since Will Miller's here, I'm just wondering how much of this overlaps for some Agile development?
We had a discussion just before, and I was telling him that I actually cover a little bit of DevOps in my course on Agile. So thank you. So there is some overlap, but there's a lot of stuff here that I don't cover either, and a lot of the really good points that have been made about the very detailed nature of how you set up for good testing and automated testing and things like that, where I'll cover automated testing, but I don't go into a lot of depth with the tools. And when I see all of the material you've assembled here with all of those tools, I know I have found it difficult keeping up with a smaller set of tools
Right.
for managing Agile projects. You got quite a task if you're going to try to keep up with, I don't know how many tools you had up there, but that's
You're not going to use them all.
dozens.
You might use 5. You
Right.
might use 6 or 8. Do you let the students self-select, or do you select them for them? Those are decisions that the teacher's going to have to make.
But one of the thoughts I had, and it came off of some of the other comments that were made here, just might be the same comment in my own words, but some of what, I think you've got a nice list of modules and everything there, and I know you had the tool inventory done, so we walked through a lot of tools, but would be very useful, and I'm sure you would do this in each module, would be to start the module by talking about why it's important, right? And setting up the criteria of how you would choose. And so I think that would be a really important part of the knowledge you would want to impart in this class, is to kind of
Absolutely.
give them give them the overview, the kind of the framework within which, so that they could go and actually make the choices themselves.
Right.
Because they're likely, depending upon the type of software development you're doing, the type of products you're developing, the nature of your business, might drive you to, some tools may just be better in those circumstances. So the criteria on top of that, so I do a lot of that in my course too with regard to Agile methods. There are a lot of different Agile methods. And so which ones might fit in your organization, students come out of my course probably, hopefully, understanding how to pick and choose among the principles and
Right.
practices that are there. So I try to hit it at that principle and practice, kind of the principle level, so that you can choose practices and tools more easily, or at least with the knowledge of what's going to work and what's not. But yeah, I do think there's some overlap. I certainly cover a little bit of this in my course.
So my experience is limited in all the Hopkins stuff. If I had my way, Sam Chappell in his software engineering course has the students write a course, write a single project. It is a clue game. It's called Clueless. If you haven't seen it, it's wonderful. And the students literally make a board and they have pieces and they play Clue. It's a simplified clue game. It's graphical. So when I taught it, I had them do it in Amazon. And instead of each person doing their own, I made them in teams. We had client, server, DevOps, and we had infrastructure so that managed the Amazon stuff. If we could scale that now in another dimension so that they took that product from the software engineering course and then applied it into a DevOps model, go from course to course, and now secure it in the information assurance module. Or you could take pieces and take a product through multiple courses to develop so I know it adds dependencies on you need to take this course before you take this course. But I think if the students were familiar with technology, it's part of the problem in teaching these kind of tools for a particular project. They get so involved in it. I mean, when we were done with our software engineering course, the grades were done for weeks, and people were sending me code changes. Look what I did, look at this. And it's really cool stuff. They want to carry that on and use what they learned in course 1 into course 2 and apply new opportunities. You got 12 more weeks. You could, let's think about that thing from I built it works on my desktop to now working client server or now working in the cloud. And now I'm concerned about security. How do I make sure that it's maintained, that it's as it was when I put it out there, that it's not changed? And how do I effect changes on the enterprise as opposed to on a single copy? So I think we have an awful lot of opportunity to use a DevOps model in many courses. It's a skill that's going to pay dividends, I think. So I don't think the DevOps is any different than, like I said in the beginning, the methods that people learn and come to experience through talking to customers. What is it that you want it to do? Here's how I think it ought to work. Let me try it. Here's this right. Let me test it a little bit. This automates a lot of that and makes the cycle time minimal and provides you a more consistent result. Any more questions? Thank you very much for letting me try.